So this little rectangle here, we've got that's spinning around the y-axis. So a lot of times what I'll do, and this will help, especially once we learn the other techniques, is off to the side kind of sketch just that rectangle. So here's that rectangle. If I spin that around the y-axis, we get this cylinder. So the radius would be right here. The height is right here. So what's our height going to be? Looking at this picture here, what's the height? Change in y, right? The dy. Right, like I said in the last problem, the height is always going to be either dx or dy for these problems that we're doing today, for discs. The radius, that's this horizontal distance from the y-axis to the graph. So technically the radius is equal to x. Right, the x value on the graph. But we're doing this in terms of y. Our height is dy. That means the integral is going to be in terms of y. We need to write x in terms of y. Our equation is in terms of x here. It's y equals x cubed. But we can solve this for x. What's x equal to? Y to the 1/3, right? Or cube root of y. I'm just going to go ahead and write it as y to the 1/3. So that's going to be our radius. So when we set up our integral, we have pi times the radius squared. So y to the 1/3 squared times the height, which is dy. Pi radius squared times height. What's our smallest y value? Just 1, right, from this equation. And then our highest one is 8. So we don't even have to find like intersection points like we did with area, although there will be some where we have to do that. We can simplify this before we put in our calculator. Y to the 1/3 squared, we multiply those exponents, we get y to the 2/3. So we can use our calculator to evaluate that. We can write it as x even though it's in terms of y on the paper. Oops. So you should get 18.6. Don't forget the pi though, so it's 93/5 pi, or if we multiply that out, we get 58.434.